Welcome to one of the largest wood sawmill factories in the world. Here, we'll take you through the complete journey of how raw logs are transported.
The process begins in the massive log storage yard, where thousands of logs are carefully sorted by species, size, and quality.
Skilled inspectors evaluate each log, marking them for specific end products. Premium logs are selected for
Various wood species serve different purposes. Hardwoods like oak and maple for durable surfaces. Softwoods like pine for interior layers. Logs are automatically sorted by diameter using laser measurement systems. This ensures each log goes to the appropriate processing line.
After sorting, logs are transported via heavy-duty conveyors to the debarking station, the first step in processing.
These massive debarking drums rotate continuously, causing logs to rub against each other. This friction removes the outer bark layer efficiently. High-pressure water jets assist in loosening stubborn bark. The clean logs emerge ready for the next stage.
Nothing goes to waste. All removed bark is collected and will be used as biofuel to power the factory's boilers. Every log passes through metal detectors to identify any nails, fencing, or metal fragments that could damage expensive cutting equipment. When metal is detected, workers manually locate and remove it, protecting downstream machinery from catastrophic damage.
Logs are submerged in temperature-controlled water ponds. This heating process softens the wood fibers, making them easier to cut and peel.
Water temperature is carefully monitored and maintained. Different wood species require specific temperatures for optimal softening.
After several hours of heating, logs are removed. They're now perfectly conditioned for the veneer cutting process. Before cutting, each log is precisely centered using laser-guided systems. Proper centering maximizes wood yield. Computer algorithms calculate the optimal rotation pattern for each log to achieve maximum veneer recovery. Hydraulic chucks grip both ends of the log with tremendous force, preparing it for the lathe. Prepared logs now travel to the heart of the operation, the rotary veneer lathe.
This massive rotary lathe is where logs begin their transformation into thin wood veneers.
The log is securely mounted and begins rotating at high speed against a stationary knife. Watch as the razor-sharp blade peels a continuous sheet of wood from the rotating log, like unwinding a giant roll of paper. A single log produces a continuous veneer sheet hundreds of feet long, moving at remarkable speed.
Precision controls allow operators to adjust veneer thickness from paper thin to several millimeters, depending on final product requirements. When only a small core remains, the process stops. These cores will be processed separately for other wood products. All cores are collected and will be used for products like fence posts, garden stakes, or processed into wood chips.
The continuous veneer sheets move to automatic clippers that cut them into manageable sizes for further processing.
Robotic stackers precisely organize the cut veneers into uniform stacks, ready for the drying process.
Defective areas are removed. These sections will be discarded or used for lower-grade products.
Fresh peeled veneer contains up to 80% moisture. Accurate moisture measurement is crucial before drying. Veneer sheets enter massive dryers, which will reduce moisture content to the optimal 5 to 10% range. Inside, temperatures reach up to 200 degrees Celsius. Hot air circulates rapidly, removing moisture from the wood fibers.
Dryers have multiple temperature zones, gradually reducing moisture to prevent warping and cracking.
Continuous moisture sensors monitor the drying process, automatically adjusting temperature and speed for optimal results.
Properly dried veneer emerges flat and stable, ready for grading and patching. Veneers pass through a cooling section to stabilize temperature before handling. Advanced camera systems scan every square inch, grading veneers based on grain pattern, color, and defects.
Each veneer receives grade markings, ensuring only the best become face layers, while others become core or back layers.
All veneers are edge trimmed to precise dimensions, creating uniform sheets ready for layup.
Veneers are automatically sorted and stacked by grade A, B, C, and D.
Premium face veneers are stored in climate-controlled conditions to maintain their quality until needed. Lower-grade veneers destined for core layers undergo additional processing to ensure consistent thickness. For maximum efficiency, Smaller veneer pieces are spliced together to create full-size core sheets. Special finger joints create strong connections between veneer pieces, maintaining structural integrity throughout the panel. High-quality plywood requires specialized adhesives. This is where our custom glue formulations are prepared. Phenyl formaldehyde and melamine urea resins arrive in bulk and are stored in these temperature-controlled tanks.
Various hardeners, fillers, and extenders are precisely measured to create the perfect adhesive formula.
Computer-controlled mixing ensures perfect consistency batch after batch, critical for quality plywood.
This is the glue spreader, where precisely controlled rollers apply adhesive to veneer surfaces. Engraved rollers pick up exact amounts of glue and transfer it evenly across the veneer surface.
Operators can adjust application rates from 120 to 200 grams per square meter, depending on plywood specifications.
Quality checks ensure complete, uniform coverage. Any gaps could result in delamination later. Now the actual plywood assembly begins. Veneers are arranged in a specific order at the layup station.